म दिपेन्द्र पोखरियाल म पेशाले इलेक्ट्रिकल इन्जिनियर हो म अनि यो हाम्रो DC chapter American Society of Nepalese Engineers को president. Thank you very much for being here today. We are very delighted to have you all here. We, American Society of Nepalese Engineers, provide a forum to share the expertise and then the experience of engineers, scientists, and the professionals of related areas of forum. So we have been organizing many seminars, programs throughout the year, and today we have another edition of that. A seminar is based on the recent earthquake that happened in Nepal. We have two experts today who has the first-hand knowledge of what happened right after it happened, and we are very delighted to have Dr. Rajesh Takal and Mr. Rafael Discipolo. Without any further delay, I would like to welcome Dr. Rajesh Takal to share us what happened there right after it, probably why it happened, and then what we can do to mitigate the disaster that happened in Nepal. Mr. Rajesh Takal.
सबैजनालाई नमस्ते है म राजेश ढकाल म अहिले चाहिँ बसाइ चाहिँ म न्युजिल्यान्ड अब न्युजिल्यान्डमा म मेरो पेशा चाहिँ म प्राध्यापन गर्छु र अहिले घुम्ने क्रममा चाहिँ यहाँ आइपुगेको छु र आइपुग्दा साथीहरूले यस्तो मौका दिएर मलाई आफ्नो अनुभव सेयर गर्न दिनुभएकोमा आइ एम फिलिङ रियली ग्ल्याड एन्ड इट्स माई प्रिभिलेज टु बी amongst you and I'll try to share whatever I have learned in my altogether 7 weeks stay in Nepal after the recent earthquake. As my background is structural earthquake engineering, I don't dare to claim that I can predict the magnitude and the timing of any earthquake, but what we can do or what we strive to do to achieve is to build up, to plan and to design and to build such buildings and structures which can withstand the effect of earthquakes, even if the earthquake is big. Actually, our aim is to safeguard the people's life and property. Right? So, as I think there are a couple of people who don't understand Nepali, I'll speak in English. So please bear with me if you find my accent a little bit different, right? And it is different. So, a quick glimpse of what happened about on that 25th of April and what did it cause, what type of damage and loss did it cause. Let's look at those highlights. So the magnitude of that earthquake was between 7.6 and 7.9. It depends on which source you look at, because they calculate there are 2-3 different types of magnitudes, and the USGS system and the Nepalese Department of Mines and Geology, they use different formula to calculate. That's why the value reported is slightly different. And then the depth of the earthquake was 10 to 15 kilometers. The epicenter, as we all know, was in between that Gorkha and Lamjung district near Barpak village. And the effects, if you look at it in a summary, more than 8,800 people have been reported to be killed. About 500,000, 500,000 houses or buildings have been damaged, and more than half of them in such a stage that they cannot be reused again. Right? And the total loss that is estimated by the PTNA, the Post-Disaster Need Assessment Group, was about $6.6 billion, which comes out to be about 1/3 of our gross domestic product. Right? So if we look at the seismicity of Nepal, actually look at the map of the world and locate or identify all the tectonic plates, we all know that the Earth's crust is divided into several tectonic plates, and wherever the boundary between tectonic plates they move related to each other, that's when the Earth triggers Earth moves, and that causes earthquakes, right? So if you look at that, actually the vulnerability is pretty clear looking at that tectonic map of the world. Nepal lies right in the boundary between the Indian plate, the part of the Australian plate is called Indian plate, and that part of the Eurasian plate is called the Tibetan plate. So in between those, right? And that's where I come from, New Zealand, and it is also equally seismically active country. So we do share a lot of similarities. Right? And US, if you look at the United States, especially in the East Coast, there are no major known faults, right? Whereas in West Coast, it is seismically very active in California. Right? So if we zoom in, we can clearly see that there are three major faults in Nepal, right? The Himalayan frontal thrust and the main central fault, which like breaks in between and carries on towards Kathmandu as well, and that's where the recent earthquake occurred, and there is main boundary fault as well. And if you look at the cross section, you can clearly see those three thrusts, MFT, MBT, and MCT. They appear different on the surface, but once you go deep, they all are connected and they join to the same fault, right? And that's the area where all these earthquake and aftershocks occurred in April and May, right? Until now it is occurring. And if you look at it, actually, there is some similarity. This is the photo I took in Alaska last year when I was visiting the Alaskan National Park. I took that photo and I found a lot of similarity between this and the Nepal's geomorphology, because one plate, the Pacific plate, subducts underneath the North American plate, and that's what gives rise to the mountain, right? In millions of years history, if you look at study the historical development of those mountains, actually it is due to a part of that is caused by the subduction of one plate underneath the another plate, which pushes the mountains upwards. And similar story in Nepal as well, right? So if you look at the historic major earthquakes in Nepal, Nepal has been seismically pretty active, we all know that, but despite that, we haven't been as well prepared as we should have been. Right, that's our fault. Nature is not to be blamed, because nature has given us enough warning. We know it is seismically prone, and we have to be better prepared. So if you look at it, one of the unique features of that earthquake which occurred in April was when an earthquake occurs and two parts of a fault, they rupture relative to each other. The rupture actually starts from one point, and then that rupture breaking process actually travels towards one direction. So in this particular case, actually it traveled towards east. And that's why actually in the eastern side, what happened is actually at different stages of that rupture process, when the seismic waves are triggered, they accumulate. So in the east, actually, the effect of that seismic wave accumulated, and the damage was much more pronounced than in the west. In the same distance, like from the epicenter, Pokhara is also about 75 kilometers, Kathmandu is also about similar distance, but if you look at it, the damage is completely different, right? And that is because of that propagation effect. So if you look at it, even the aftershocks, most of the aftershocks that occurred after that April 25, most of them occurred towards east, right? And even major aftershocks as big as 7.3. But one unique feature about the aftershock, if you look at it, you can clearly see the aftershocks in terms of number of aftershocks per day, and in terms of the maximum magnitude of the aftershock every day. If you look at the trend, it was clear that the aftershocks kept thinning. The frequency went down, and also the magnitude went down gradually. But apart from that one 7.3, which actually defied the trend. And it caused surprise to many seismologists as well. And they were saying that the probability of that earthquake, that big aftershock happening 17 days after the main event was about less than 1%, right? But still it did occur. So that is normal. And even if you look at the intensity map, always they are dominated towards the eastern side. So on the eastern side, the damage and intensity, shaking intensity was more than the western and other direction. That is the directivity effect. So let's keep all those aside. So finally, the earthquake did occur. And The earthquake accumulated with the aftershocks created a lot of effect, and as we already summarized, it killed so many people. It made many families homeless, right? But overall, there are many buildings which collapsed, right? And collapsed buildings not only in Kathmandu but in hilly districts. Not only the buildings made of stone and rubble masonry, but even the brick buildings, even concrete buildings. There are several buildings which collapsed. You can see some of the photographs I just took when I was visiting around, and several collapses, right? So you can see that. So this is a picture from Bhaktapur Darbar Square. Among the Darbar squares I visited, this was definitely one of the most heavily damaged, most severely damaged. It was very badly affected, and you can clearly see like the buildings around the Darbar Square very severely damaged, and they are the soaring has been done there to keep it intact, at least for the time being, until the government and the local administration makes a major decision about what to do with this type of buildings. And that is a huge challenge, of course, in Nepal, given the lack of preparedness. Actually, it's a huge challenge for the government to finally manage the disaster or the devastation caused at this large scale. Right? So this is Patan Darbar Square. Again, the damage was substantial, but not as severe as I saw in Bhaktapur Darbar Square. A lot of our temples are still intact. There are some sporadic damages, the discrete damages which can be easily repaired. And Kathmandu Darbar Square, and you all have seen the Darara's picture, because it feels so sad to just even look at it and find that it is completely missing one of the landmarks of our Kathmandu city. Right? So damage to that Hanuman Doka is quite severe. Probably, I don't think that they can probably restore it. It is pretty severely damaged. Right? And Pasupati Gwesuri area, surprisingly, people also make a joke about, okay, the God at least took care of himself, like, because there is not much damage in the Pasupati area. It's really surprising. Yeah, and Swayambhu, yeah, there is some damage, especially to the spire. You can see quite heavily. It was stopped. The public access was stopped after the earthquake, and when I went there, I had to get special permission to go there to inspect the buildings. And it's, they are doing the renovation. Probably by this time it might have already been opened again, but I'm not sure. There are some damages. Right? Sanku, one of the very heavily damaged areas in Kathmandu, and mostly because the buildings are really weak, or easily we can say, even without earthquake, that the buildings are not very well equipped or well prepared to withstand any level of shaking like that. Right? So it is one thing we have to understand is earthquakes don't kill people, bad buildings do. Right? So we shouldn't be blaming the earthquakes on nature. That is, nature is one part of it, and the second part is artificial, which is the structures and buildings which we build, we conceive. So we have it in us. We have the ability to make the buildings in such a way that actually it withstands that level of shaking without killing people doing it. Right? So this type of scenes is very common. Like if you drive around in the ring road area, you see a lot of tilted buildings which have got the ground story completely collapsed and the buildings tilted. Right? And a tilted building, although not collapsed, but these types of, like the building tilting, and this tilt is pretty common in many parts, right? So yeah, it is the one interesting thing is it has caused a lot of dispute between neighbors. The neighbors who used to be very good neighbors and used to take care of themselves, now suddenly because of this dispute they are arguing, your building is tilting, the other one is saying your building is tilting, you should demolish yours, you are putting us in danger. So it's a lot of quarrels, a lot of disputes among neighbors, and that has been the source of that. Just on a side note, actually, those kind of scenes you can see very clearly. Right? And House of Souls, like this is one of the colonies, recently the Padma colony in Sitapaila. I was so surprised to see this because the developers have done, it is a technical crime. Like what they did is actually you have got a hilly slope, a hilly area, and in the hilly area you have to develop the whole colony. So what they did is actually they put a retaining wall, small retaining wall, and filled half part, dug half part of it and filled the other half, didn't compact at all. And then they built a building, the foundation is like 4 or 5 feet down, which is in half of the building, it is in that filled area. So the filled, not even properly compacted soil is taking that whole load. And when it shook, the way the earthquake shook the building and the colony, the the damage to that retaining wall, those houses. You go inside the house, half part is fine because it is well founded on hard rock, and the other half, the building has just curb. So it is antiquely easily. It is a designer spot. Whoever designed it, actually carelessness. And damage to walls is a very common sight in Kathmandu. You go to most buildings, like hardly there are any buildings without cracked walls. It is pretty sad to see those. Although they are structurally okay because they take a lot of time to repair, and people occupying those buildings will have to move out. So in terms of economic consequence, they cause a lot of loss to people and to the community. Right? And tall buildings, if you look at it, there are many tall buildings in Kathmandu these days, and in most of the tall buildings that I visited, the damage was mainly non-structural. Means like the structural part, which is the columns and beams and the floors, they are okay. But the walls in between, the ceilings, those sort of parts which do not transfer the lateral load, but still are important in any building, they are very heavily damaged, and non-structural damage is pretty common. Right? And typical condition of most high-rise apartments, you can see those types of scenes. Like in most high-rise apartments, this is from Sunrise apartment in Nakku. Similarly, Silver City luxury apartment that is in Kalikastan. Again, pretty severely damaged walls, but structurally very sound. No problem. And this is Parkview Horizon, one of the most badly damaged buildings and very controversial because the damage was so severe that our team didn't even dare to go inside. Right? So I took those photos from outside. Very severely damaged walls, and the panels fell off, and even one lady was killed because she wanted to run outside, and a heavy brick panel, wall panel fell off on top of her, and she got killed. Right? So this looks like the most severely damaged high-rise apartment.
Why it is controversial?
The controversy is actually because the dispute between the occupants, who are, of course, who can pay 2 crores, 3 crores of rupees, they are people with high-level touches, high-level links, and they are putting pressure on the government, especially the Ministry of Urban Development and Building Construction, to make a swift and quick decision on it so that they can go ahead with the repair. Whereas the engineers working on for the government, they are not sure at this stage whether it is in a repairable condition or not. So they are indirectly trying to put pressure. Right, to make hasty decisions, and they were just they were just coming to the department and with all those high-level people putting pressure on the Director General. So buildings in progress were also not spared. So buildings which are under construction, they also got damaged. I saw many pieces of that, many examples of that. People, they were of course, understandably, they were too scared to go inside the home, and they just stayed, most people stayed many days outside in tents and others. And they just started, in every community, they started putting, like some Santi Sabha, the Sammilan Gorera, and just praying to God for peace and calmness. That sort of scene was not uncommon, right? Many families living in temporary shelters, and even your relatives and family, you might have heard that they spend weeks in tents outside, right? And that was actually in Kathmandu. People, despite having their houses intact, they were staying in home. But in Sindhupal, so this is one of the 3-4 districts that I visited, and definitely one of the most severely affected district. Almost the whole district, whole Chautara Bazaar was running in tents. Because the hospital was damaged, the government district office was damaged, the education office was damaged, the police headquarters was damaged, everything was damaged. Right? And it was really bad. Actually, in Chotara, I was extremely surprised. So everything was running in the tent in the Dodikhel area there, right? And one of the typical thing that I noticed in Chotara and a couple of other places was because the houses that were on the ridge of a hill, like Chotara Bazaar is on the ridge of a hill, and not even a single house is intact, right? Everything will have to be demolished, right? So that ridge effect was pretty obvious, like whatever was built on the top of a hill was very badly damaged, and the similar building of similar material and similar era or a similar vintage, if you look at one on the lap of the hill, it was okay, with minor surviving. So that was even the case in Gorkha. Actually, I noticed that in Gorkha as well. The Gorkha Darbar had some quite significant damage. Whereas you go down in the Gorkha Bazaar, It's not much. So similar buildings. It was quite common and a lesson definitely to be learned by the researchers. They are exploring it, right? And I saw this is the Gorkha Darbar. You can see that all the tiles on the top of the roof were displaced, were thrown here and there. And in order for that to happen, the acceleration at that particular location has to be quite substantial, because it has to overcome the frictional coefficient, and it has to also overcome any sort of anchorage that the tiles are done with, right? So, for many collapses, the cause was quite obvious for engineers, because there were easy, clear signs of bad design, bad construction, bad, poor material, right? So I have put some slides there which speak for themselves, like pretty common, like for engineers, civil engineers who have done engineering, you can clearly see, like in those damaged places, this level of reinforcing bars in 5-6 story building is obviously not enough, right? And insufficient confinement, poor detailing of reinforcing bars, like the ring or the ring bars, the stirrups which we call, they are not properly spaced, they are not properly anchored. So all those details you can clearly see. I took a lot of, this part is more technical, so I'll skip through, because obviously what I want to say is the signs or the causes of those collapses. There are several factors leading to it, and among them few I have listed here. Right? So the material quality was very poor, because you could see a lot of signs of corrosion. You could see, like the cover thickness not enough. You could see the concrete quality. Even in the damaged buildings, you take out the concrete, and even with finger you can crush the concrete. Like it is a clear indication of almost no strength in the concrete material itself. So pretty bad. And surprisingly, the plaster thickness in buildings in Kathmandu was very thick. You never see this kind of thickness anywhere in developed world. And I don't know what goes into the mind of those masons or those people who build it. Probably they think that the more copper we put it, the better it is. But it is adding to your weight of the building, which directly adds up to your seismic force due to the earthquakes. So unnecessary short column effect, these are technical. Deep beams and slender columns is pretty opposite to what we teach in earthquake engineering. When we say, like, when you design frame buildings, you always have to make sure that your column is stronger than your beams, and it is the opposite in Nepal, right? Most of the construction you see deep beams, very small columns, like 9 inch by 9 inch with 4 bars in it, and they keep on adding stories over stories after the year. So it is pretty careless, reckless, or probably they don't know, the owners, but the regulations should have stopped that from happening. And we don't have that robust regulations, right? So awkward framing system, different kinds of examples. Cantilevers, you bring out cantilever, and then above the cantilever you put heavy weight, or you add 2-3 stories above a cantilever of 2 meters, like which is technical crime. That shouldn't have happened. No gap in misaligned floors. That is, I couldn't stop thinking about pounding. Like when earthquakes do occur, 2 buildings move, and when they move, they hit each other. And if the floors are not aligned together, and if the gap is not enough, then when one floor hits the wall or column of the other floor, there is a high chance of this building being collapsed. Okay. So it should be good. So after all of this, like when I talked to many engineers, when I interacted with several people, I felt that the engineers were confused about 2 things. The first one was severity of the monsoon, right? Because a lot of international experts went there, and what they started saying is, okay, for this big earthquake, the magnitude is 7.9, only 75 kilometers away, and the damage we are seeing, damage is too little. So the shaking, this was not a big shaking at all. Right? So they are saying that a lot of big experts, big so-called like world experts are saying that. And people, on the other hand, they remember their feeling very strong or very big shaking. Right? So where is the mismatch? Actually, the mismatch is when we feel it. We have perception to feel the displacement, how much is displaced. Right? Whereas what damages the structure, it is not the displacement. It is the rate of change of displacement or rate of change of velocity which gives the acceleration. So for the building to be damaged, you need to have even smaller displacement but happening very fast. That will give rise to large acceleration which damages. So what happened in this particular case is actually Kathmandu. Do I have that slide here? Let me see. I do have that slide. Let me talk about it. So the shaking, what happened in Kathmandu is actually the displacements were large, but the acceleration was small because I felt the second earthquake. I was already in Kathmandu, the 7.3, and it was quite obvious to me when I compared with the shaking we felt in New Zealand back in 2010, 2011. It was in New Zealand, it was moving really fast, whereas here it was kind of rolling motion, right? So large displacement, but the acceleration was small. And that actually, and for people it was big shake, but for structure, it was not as damaging as it could happen. Right? And why it did happen like that in Kathmandu especially, because not in hilly districts, is because of the soil formation of Kathmandu. It has got that large deposit, deep deposit of the clay soil, and which actually filters out your high frequency component and only passes with amplification, probably the displacement amplification, the low frequency component. And that's why we felt like that. And so the soil actually, in fact, to some extent, reduced the damaging ability of the shaking in Kathmandu, but not in the hilly districts, because you have got rocks, you have got hills, and which doesn't filter out the high frequency component. So in those ridge effect in the top of the hill, probably the shaking, the acceleration was bigger. Right? So the second confusion for people was actually because in this earthquake, what happened is actually you saw a lot of those high-rise buildings, modern buildings which are properly designed, have undergone so many cracks and damages. For people, those cracks are damaged, okay? Whereas for engineers, cracks are normal. Right? So for people, they saw a lot of damage. And then the load-bearing system, the wall buildings like 1-story, 2-story brick wall buildings, because they are so stiff, they didn't suffer much damage. So whereas the engineering science says, what it says is actually frame buildings are better than load-bearing buildings, right, for earthquakes. And the kind of observation by people was just opposite of that, almost opposite of that. So it has created a question mark, confusion in people's mind, right? They are starting to doubt that theory. So the problem is actually because when we build or design buildings in frame system, what we do is actually we allow the building to move, because frame by itself is very flexible, whereas a stiff wall by itself is very stiff. Right? So the deformation is small in stiff wall, but once its capacity is exceeded, then it breaks. There is no ductility, there is no ability to hang on. Right? It collapses and it kills people. Whereas in frame buildings, despite undergoing large displacement, there will be cracks in beams and columns, but it doesn't collapse. So that's why, because we don't intend to design buildings which doesn't damage at all, or which doesn't crack at all in big earthquakes. Nobody can do that. Even the most advanced engineers in the most developed country like United States, New Zealand, Japan, they also can't. So buildings cracking in this big earthquake is normal. Right? Whereas buildings collapsing and killing people and people losing their properties, that's not accepted. Right? So that is the aim. So a little bit of confusion there. So people have to understand that probably because of that level of shaking which I talked about and the Kathmandu soil, because if you look at it, probably some of you who are engineers might understand that, structural engineers, the response spectra. If you look at it, in the long period range, the energy released or the demand was so high. So this long period means those tall buildings, very flexible buildings, they are into that range. So for those buildings, the earthquake was more demanding. Earthquake was more damaging. Whereas for very stiff system, for which the natural period is very small, in this range here, very close to 0.1, 0.2 second, the earthquake caused very small shaking, very small effect, right? So that's why those one-story stiff buildings, they survived with minor damage, whereas the tall buildings had more damage in it. And this I already talked about Kathmandu Valley's clay deposit, which filtered out the large high-frequency component and only transferred the low-frequency component with amplified displacement. The displacement was 1.4 meter, which was quite substantial. So if you look at that and reflect on it, like what I felt is actually, in fact, in terms of knowledge, actually they have reasonable knowledge in Nepal. There are engineers who do understand how do earthquakes affect structures and buildings and how to prevent them. So they have even documented that pretty well in terms of the preparedness. I could see some knowledge, but the application of that knowledge into practice was really poor. Right? It was very, the preparedness was very, very low. Right? So you can see, like in new buildings, when you go to the new buildings and look at the structural system, very sound structural system. You can compare that to any construction happening in advanced world, even in seismically active advanced world. You can compare that and you feel, oh, at least there are people who are practicing, following good practice and doing whatever should be done in this type of situation. So that is an indication of knowledge, existence of knowledge there. Right? You can see the engineers' advice are being sought, at least at corporate level, right? All the big banks and companies, they immediately, like hired engineers to do the checking of their buildings and giving a certificate of clearance, and that did happen. So it is a good practice, but it is only a small proportion of the buildings I'm talking about. Not the other, not the rest. And the building tagging system was also very internationally calibrated. It was exactly what we did in New Zealand. It is exactly what they did in Japan. It is exactly what they do in California. So there is nothing inferior about it. They follow that practice. But the problem is actually the ability of the people to understand what these mean. They don't understand. They think that once it is red tag means it must be demolished. And when it is green tagged, they think that it is safe forever. Because that is not the purpose. The purpose is simply to go into the field and look at each building and look at their damage and decide, has the building situation changed compared to the pre-earthquake stage. Right? So if nothing changed means you are staying there before the earthquake, so you can carry on. Right? Whether it has to be made stronger or it would survive or not, it requires a more detailed study. It requires a building evaluation, not a damage assessment. Damage assessment will only allow you to tell that, okay, because of those damages, the building situation has worsened substantially. It is like visiting a doctor. When you undergo an accident, you will have scratches everywhere, and you go to a doctor. Doctor will see just those scratches and probably, nothing has happened. Just use some medicine, and you will be fine. You will probably not require any X-ray or anything else. If the damage is severe, then you will require further assessment, right? So that is kind of screening purpose. So soaring and protection, it was common, but main thing is you can see where the focus should be. The soaring is almost non-existent, and a small idol of a god has been protected that well. Okay, so it's an irony, right? So you can see the soaring is happened like that, a very dangerous area, and people freely walking through. Demolition of dangerous building, that is an immediate challenge because there are several buildings which are not completely collapsed but damaged so badly that even in aftershocks they could fall and they could affect the people around them, right? And they need to be demolished for safety of the people, but we don't have skill and equipment to demolish all of them, and it's a huge challenge. Management of debris, like all those collapsed buildings, all those debris, what to do with them, it is posing another challenge, and the government has to be really proactive about it, smartly think. Right. So the immediate issues, if you look at it, one thing is, as I said, misinterpretation of color tags was pretty prominent, because this slide I prepared about a month ago, so that's why probably now no longer that issue is immediate, because we have already passed through that phase. Crack phobia, that was a big issue. I did a lot of awareness program, right? Public awareness program, even engineers awareness program, because crack, when we see crack on the walls, they get so scared, and they think, even engineers start thinking that, okay, this building has to be demolished, it has been damaged very badly, but it's not so. It's completely normal for concrete buildings to crack. Many engineers not able to distinguish between structural and non-structural damage, and between repair and retrofit. So damage and scale of event. We didn't have enough engineers with earthquake engineering knowledge. There were experts. They have expertise in geotechnical engineering and advising about building damage and building repair. That professional ethic wasn't there. Scarcity of demolition skill and equipment, right? So I got involved as much as I could. In those 7 weeks, I did work morning, day, and night, all those 7 days a week, almost 24 hours, and I did participate in many activities, like public awareness program, through media, through radio, television, newspaper, even in the community circuit, like community people are organizing the awareness program for their community, and I went there and explained them what they should look at when they look at their building, all those things. And building inspection and counseling, I did inspect a lot of important, strategically important buildings and explain to people what the situation of the building was, and convincing the counseling was a major part.
May I have your attention, please? Lateral close.
Like I just like, okay, this is what you should do when you build reinforced concrete buildings. So even if your house owner doesn't tell you that, please do so. It doesn't cost extra money, but it makes your building earthquake much safer in earthquakes, right? And they did take my advice, and they said, they promised to me that from now on until they die, whenever they build a building, they will follow those 3-4 advices. Right? And I explained to all my junior engineers whenever I gave the lectures that, okay, look, don't wait for government to invite the masons and give training. You can simply, wherever you see a construction site, you can just go by yourself. You are an engineer, and just those 3-4 major clues, just tell them, show them like in the bars, how they should bend the bars, what they should do. And if you can influence those 10 masons, you would have done your job. If all of us engineers do that, it will be a really good outcome, right? So assessment of important buildings, we did. I was involved in assessing many government buildings and strategically important, like those high-rise apartments and all those, assessing hospitals and advising medics, Beer Hospital, Teaching Hospital, the Kalimati Hospital, 3-4 hospitals. I did go, and I had to convince even the doctors, saying that if you are scared to be in this building and operate, because in that time when people need the hospital services even more than normal time, we can't afford to close buildings because of those minor cracks. So what did I say to them is actually, give me an office, I will make my office in the top floor here. Okay, I'm an earthquake expert, earthquake engineer, so I'm a structural engineer, so I will have my office there, if that gives you a confidence. So I had to go to that extent to convince them to come back to that Beer Hospital thing, right? So all those things would happen, and advising government officials, secretaries, they all wanted their office and their buildings to be guaranteed to not collapse in future, right? So it's like that. Interaction with senior engineers, professional speaking, advising outside their area of competence was common, as I said, and I had to explain a lot of them what is the difference between repair and retrofit. What is the difference between damage assessment and building evaluation? Damage assessment is you are only looking at the crack and telling in relation to what it was before the earthquake, what is the deterioration. You can't say what is the level of, or what is the remaining capacity of building by looking at the damage. You can't say that. You have to look at the building as a whole with the drawings, how many bars are there, what is the size of the columns and beams, and do some calculation. Then only you can tell what is the strength of it, right? So training or raising awareness among senior engineers, and talking to junior engineers, big masses of junior engineers in different colleges like Pulchok and the KEC, ACME, Purvanchal campus, all those places I went and talked to hundreds and hundreds of engineers, junior engineers, like final year students and fresh graduates. And again, those basic awareness, raising awareness program. So last slide for me today. So where to from here on then? As I said, big earthquakes cause unbearable pain, of course, right? As I said, earthquakes don't kill people, bad buildings do, so we have to be better prepared. But the earthquakes also provide a golden opportunity to develop a more resilient community that is better equipped to combat similar disasters in the future, right? So, for example, I can give you an example of my hometown, Dharan. In 2045, right, 45 saal ko bhukampa. In that earthquake, my hometown was very badly damaged, and 700 people got killed only in Dharan and its surrounding. And my house was also damaged. We had to build a new house, and we were involved in rescuing people. So with this on hand, actually, I have pulled out probably a dozen of people buried inside and saved them with other friends of mine, right? So that city now, in this earthquake, actually the level of shaking in that city was similar to, if not greater than what it was in 2045. And now look at this, like despite similar level of shaking, the damage in Dharan is very minimal. Because Dharan has emerged out as a more resilient, more stronger city. Because all those vulnerable buildings, they got either demolished or damaged so heavily that they were rebuilt. And while rebuilding, they applied whatever latest know-how they did have, right? And they were, because after the earthquake, always the level of cautiousness in people are very, very cautious about how we should build buildings. But with time, slowly it fades away. But now it is still fresh in our memory, and even despite the government not putting a lot of huge rules and regulations, the building owners will be very careful from here on. Naturally, it comes naturally, right? So the things that we should do in long run is actually we should develop and improve the building codes. It needs to be done, and I am being requested, or the government has requested me to be involved in revising the building codes, and I intend to be involved, get involved to some extent. Establish robust construction quality control mechanisms, because the quality was really, really bad. Not only the material quality, also the construction quality level of workmanship there was obvious. Establish mechanisms to ensure, because not only having the codes and rules and regulations, that doesn't mean anything. We have to implement them, and implement cruelly and very strictly. Right? So we need to develop mechanisms to ensure that those rules regulations are followed as strictly as possible. State-of-the-art earthquake engineering education and training for capacity enhancement, because now there are shortage of earthquake engineers, but in future we will have to be better prepared. And I have had a series of discussions, meetings with the Dean of Institute of Engineering and Kathmandu University to start an earthquake engineering research center in Kathmandu, and also to start a specialized earthquake engineering master's program. Right? So urban development strategy has to be based on a sound land use planning, because you need to have, it is an opportunity. Those areas like Gongabu, Sitapaila, all these places are have been so badly damaged that a new reconstruction will have to start. And then in that particular case, it has to base on land use planning. So proper land use planning has to be done based on what is the local soil type, how strong or weak it is, and to what level of load it can bear. All those things will have to be taken into account, and the preservation of the nearby area, environmental factors, tourist factors, which areas should be developed as a transportation hub, which areas should be developed or allowed to build those high-rise buildings, because having a high-rise building 23-story in the middle of Kalikastan, although structurally it might be okay, but it is not a good decision. Because it is not those, like 200, 300 families who live there. But in addition to that, what you also need to do is actually to plan for the other related infrastructures those people will need, that building will need. The water supply, the transportation, the car garage, all those things, right? And it will put huge pressure in the existing crowded community already there, right? So the government will have to make a land use plan and identify areas where high-rise building development could be allowed, and then they should keep some clearance between those buildings and other developments. So that type of planning and thinking isn't there at all. So that has to start from now on, and develop comprehensive soil mapping, because soil is one of the issues in Kathmandu, especially in Kathmandu Valley, because of the weak soil. We have seen a lot of cases of uneven settlement, like your building has a footprint, and in that particular area, because of the soil unevenness, what happens is one part of the foundations subsidizes more than the other, and building tilts. Right? So while it tilts, although structurally there might not be many cracks, you can't push it back. So people don't feel comfortable living in it, and it becomes uninhabitable. And it could happen completely avoided if proper foundation design matching with the soil nature, if that had been done. Right? But it wasn't done. And the government, I have suggested the Kathmandu municipality and the Department of Urban Development as well to do a comprehensive soil mapping of Kathmandu Valley. Similarly, other territorial authorities, local authorities, councils will have to do in their territory as well, do the local general mapping. And for those people like you and me who want to build 1-story, 2-story house for residential purpose, for that you don't need very detailed soil investigation. So with that general soil mapping, you can give some guidelines on what type of footings or foundation you need, right? Whereas for commercial buildings and those high-rise buildings, you need to do a detailed study of the soil, because if they are spending that many rupees, then they can spend few more in having a soil investigation. Whereas for residential purpose, the government will have to give basic information necessary for that, right? And which is enough to plan your normal residential building. So those are the things actually you must do from here on, and there will be efforts towards having those. I don't know how effective or how successful we will be, but we will definitely try our best. So having said that, these two slides simply give us a positive message that despite all those earthquakes and aftershock, despite all those damages and collapses, still Nepal, the beauty of Nepal is still intact. There are places worth visiting, and even it has added one more dimension, one more cause to visit Nepal, which is to see actually how that beautiful nation has been affected, right? So definitely there is a positive touch to it, because we shouldn't be afraid of encouraging people to visit Nepal, because as it is not like not as bad as what the media is suggesting. There are pockets of heavily damaged areas, but there are many parts, major parts of the country is still intact, right? So with that, I end my formal speech, and I look forward to interacting with you during the question and answer session. Thank you very much for that.
Here, Dr. Dagal. I'm sorry, I apologize because I did not introduce Professor Dagal very nicely. I'm going to read his illustrious bio, a very snapshot of it. Dr. Rajesh Dagal is a professor of electrical and earthquake engineering at University of Canterbury and a fellow of Institute of Professional Engineers, New Zealand. He is a chartered professional engineer in New Zealand and led several building assessment teams following 2010-11 Canterbury earthquake in New Zealand. Professor Dagal has authored more than 250 technical papers in different aspects of structural and earthquake engineering, and is internationally known for his expertise in the field of earthquake engineering. Professor Dagal spent more than 7 weeks in Nepal right after the earthquake and will be spending the rest of the year assisting government of Nepal for recovery and reconstruction effort. Professor Dagal was born and raised and educated in Nepal. He received his bachelor degree in civil engineering from the Institute of Engineering. For his outstanding academic performance, he was conferred Vice Chancellor Gold Medal and Kulratna Tuladhar Medal. Currently in Christchurch, New Zealand, Professor Dagal is also a president of Nepal-New Zealand Friendship Society of Canterbury, for which he co-led NG for Nepal fundraising campaign after 25 April Nepal earthquake. The campaign has so far generated more than 100,000 New Zealand dollars, more than half of which has already been used to provide relief materials to thousands of earthquake victims in Nepal. Professor Dagal came to Nepal as a member of expert engineering team sent by New Zealand government in response to the government of Nepal's request. Since coming to Nepal, he has helped assess several government buildings and other buildings of high strategic importance, such as hospitals, high-rise apartments, etc. With that, we have a question and answer session, but before that, I have an announcement. We are lucky today to have here an RN President, Dr. Keshav Paudel. So we'd like to welcome you here. And we have a coffee and some.
8 minutes of time to complete the question and answer session before the music starts. And so I'd like to take from the first row, starting right here.
For your very enlightening talk. Of course, there is a paradigm shift going on, and of course it has to be. And in the due course of the time, especially with respect to urban planning and the house reconstruction, I think we need a whole new way of dealing with all this new development. But I have a question that goes a little further, larger. We are pinning our hope on the development of the mega hydro, mega hydro project, because that is where the nation's, biggest, largest resource lies in for the future development. And most of these mega hydro projects, they are, going to be built. They really happen to be in a Mahabharata range, which is, from a geological point of view, are very young mountains. I mean, nearly 10 to 15 or 20 million years old at the very most, right? So And most of these range, they actually, happen to be on the fault line. Well, I'm not the expert in that line, but it's just my, layman's kind of, view. Now, given this kind of the situation, what is your take on, building a very large mega hydro project in such a, a seismic fault zone? I mean,
as an engineer, what I want to say is being in a seismically active zone is not an excuse not to develop.
I see.
So, because there are solutions to everything. Because once we understand, like what is the likelihood or the magnitude of earthquake that is likely to occur, we can design even mega projects, mega structures to withstand that. So a proper technical knowledge and input, if it goes inside it, then there is a solution to it. So we should definitely, because if we all know that hydropower is one of the major resources that Nepal can utilize for development in future, and we have to tap those resources, and that is an opportunity to develop. And if it happens to be closer to seismically active zone or closer to a fault, so be it. We can design for that. So technical know-how is yes. Yeah.
Thank you, Dr. Rakal, for excellent talk. I think everyone enjoyed today. I have one question, just this short question that after your talk, I realized that we have some knowledge and we have some practices. Maybe we don't have the attitude. So I have seen in the history of Nepal, there are so many times we were suffering from earthquake. So what would be your suggestion to the government and the engineer colleagues? Just if you have to say in one word. Already passed to the government officials, even to ministers, secretaries, even in parliament, I have already said, is actually because capacity development, right? So that is, for long-term planning, that is the main mantra, because if you can't rely on the foreign people to come and solve your problems, because if we want to develop buildings in our remote areas using the stone, bamboo and wood, we need to do research. Japan will not do research for us, America will not do research for us, right? So the research center has to be developed in Nepal, and which needs to study those typical problems which are unique to our soil, our background, right? Whereas for advanced structures, reinforced concrete buildings, we don't need to do any research. Whatever information we need, we can borrow from the developed world, right? So that is definitely, because that think tank will have to invest in that capacity development, which will come only if an earthquake engineering research center which looks into the local problem, earthquake-related problem inside Kathmandu and Nepal as a whole will be there. Because if I have to choose one out of many, then that is where it should be.
Dr. Dutta, for a very, very comprehensive and actually a real picture of Nepal and where we should be headed from now. My only question is, it's not really technical, it's probably planning and administrative type of question. The question I want to put forward is, seeing the pictures of the presentation in the slides, it looks like Kathmandu is in a verge of collapse. If another earthquake comes in, and if that happens to be path of an earthquake. So, and I really agree with you regarding the zoning of land use, which we do over here. I've been practicing that for almost 10 years now. That is exactly what should have been done. We missed the point. Now, seeing the situation, how is your feeling when you reacted with the government officials in high level? Are they even thinking of shifting the capital somewhere outside so you can make a density base in Kathmandu with small buildings? Or are they still thinking, we'll retrofit this building and let the people move in and let's see what happens? What was their reaction? Were they thinking of doing something like a satellite city or something so that the density can be reduced in Kathmandu?
Yeah, because to be honest, I have to be frank here, and what I felt is actually the people who can make the policy, especially the leaders, the ministers, they were clueless. They didn't have any clue how to come out of this situation. Right? So, to be honest, all other sectors were praised for their role in aftermath of the earthquake, like the engineers, the doctors, the youths, even the volunteer organizations, all sectors, press, media, everybody's effort role was lauded apart from political leaders.
a key issue, but not being involved in Nepal's political bureaucracy over the last 20 years, I decided not to interrupt in that particular way, because I only try to contribute to be as helpful as I can, given my expertise in the area. So in that particular case, actually, I did train most of the engineers working in the Ministry of Urban Development, civil engineers working on that, explain them what is the difference between repair and retrofit, what level of damage can be repaired, and when you retrofit, how you should do the building evaluation. So all those things were done. So technical input I did give. In terms of policy, I did talk to the Director General and told them that in terms of retrofitting, they must have a policy. Because the policy must be such that all important government buildings, non-government, taller than 3-story buildings will have to be evaluated, assessed in terms of their capacity. And if the assessment gives an impression that the building is weak, then they must be upgraded to a certain level. And that has to be a law. And that is what it is in New Zealand. We have a law which says that within the next 5 years, all buildings apart from 1- and 2-story residential houses will have to be assessed, and if your strength comes out to be less than 1/3 of the new design value, then you must bring it up. So that is a law. So that level of that has to be done, right? Sooner or later, if we want to see Nepal emerge as a stronger and more resilient country in terms of earthquake resistance in future, because the next earthquake is not a matter of if. Earthquake will definitely come. It is just a matter of when. Right? When will come, we can't tell. Nobody can tell. But we have to be better prepared in future earthquakes. Otherwise, our children and grandchildren, what they'll think about us. We didn't learn any lesson out of this experience, and we didn't prepare a better place for them to live on. And then, हामीले देखा छ नि त्यसो त थियो हैन त्यो हिसाबले हामीले चाहिँ we have to try our best. So I think
my question is just connection with the gentleman, I don't know the name. So I think attitude. Based on my experience, I think we know the science somehow, we know the technology, and that's easy. These days, I think it's kind of people can do the leapfrogging. I think my observation is like that. They have their, the priority, different agenda, and then which leads to the lack of motivations. I think, is there any kind of pills? Just a single pills, we can dose them or bring the changes of attitude. I think that's the best thing. I think it needs to move forward, I guess. Yeah. Anything we can bring this kind of message to change at a high level. Even we make a policy, anything, we have guidelines. If attitude is bad, I think everything is gone.
Yeah. Because attitude to what I focused on my last slide was implementation, like, because we can do any technical things. Technically, like, we know how to build buildings, we can make documents, we can make codes, we can make rules, we can make regulations, but if they are not implemented well, then actually the outcome will be nothing, right? We will not gain anything. And this, whether it is implemented or not, actually there are two ways of doing that. One thing is coming from inside, that is attitude. Like, the people will have to be self-conscious, and it has to naturally come from inside. That's probably what happens in most of the cases. The personal assistant misused the donation amount or some goods coming out of that, and it was proved. And after having proved that, what they did is actually they just took him out of his job, right? So he is no longer the personal assistant or personal secretary of the parliament. Where is the punishment? So if that is the case, okay, if I try to do the same thing, if I am caught, I will give up this job and find something else. Right? So the example, very bad examples we are setting. So it's very bad.
Mangal Mahajan, so Dipendiji gave me for part of the session host. First of all, I would like to say thank you, the first presenter, Mr. Dr. Rajesh Tajal. Let's give him big hand, please. We have very interesting presenter now, Mr. Rafael Discipolo. Before that, we have short speech will be delivered by Dr. Keshav Paudel, NRM President. Please, I would like to request you very shortly, we have running the time, please your short speech, please.
Good evening. Thank you for this opportunity. I was not expecting any speech or anything, but thank you for giving me this chance to talk to you. I really enjoyed the talk by Dr. Dakal. It was very nice, and it was very nice of him coming out here and educating all of us. Thank you. And also I would like to thank American Society of Nepalese Engineers, DC Metro Committee, who organized this program to educate all of us. And thank you, Surya Lamsal, who is the member of board of NRN, who informed me about this program. So thank you, everyone. Today, we all know Nepal struck by a big earthquake, and it's not the first time. So we have been having this kind of disasters quite often. We should say quite often. Dr. Dakal said, so there was one big earthquake in Dharan area a few years ago, and we have heard 1990s earthquake and so many small ones. So as I mentioned before, I think we all know Nepal is a place very prone to earthquakes, but still we are not well prepared, and we have not done enough to prevent this kind of disasters in the future. And the problem, I think, everyone knows, and we try to practice, or we believe that we are practicing. But there are no rules, no laws, no policies from the government. And also, as a part of the citizen, or the duties of the citizen, or the people who are supposed to suggest that kind of changes or apply in their life, I have to say mostly engineers. They should try to enforce, all of us should be able to enforce that this kind of rules should come to prevent future disasters. And I would like to urge everyone here and people in Nepal that this is the opportunity. This is a disaster, this is a problem, this is a challenge, but we need to change this challenge into opportunities, and we need to start from the new beginning. We need to plan good, and we need to try to make the policies like zoning or organizations or whatever, make a safe place for the residential areas or high-rise building. We need to find what are the best locations, what are the appropriate locations. So thank you all the people who are outside the country. They are helping Nepal. They are all NRNs, non-residential Nepalese, wherever they are living in US or Australia or New Zealand. There are 3,500,000 people living outside the country, and they are trying to help Nepal, even though they are not staying inside the country. They are always thinking of Nepal, and they are thinking to improve, and they always be happy when Nepal becomes a better place to live. And we always, our heart always breaks when something bad happens in Nepal. So from all of us, we should try our best to help, and we should try our best to give our suggestions, and also we'll try our best to help Nepal go through this disaster and tackle through this disaster. Thank you for this opportunity, and as an NRN, we are helping Nepal, and we also wanted NRN to be given the good place. We were looking for the once a Nepali, always a Nepali, but that hasn't been successful so far in the constitution that was just drafted 2 days ago. And our demand will be, so once you are a Nepali, you should be able to be a Nepali without any conditions or clause. You are always a Nepali, you helping Nepal, you loving Nepal. There should not be second-grade citizen that you are outside the country, and you should not be able to have the privilege or the rights of the country as a citizen. So our plan in the future would be continuing to fight for our rights. We also try to help Nepal. We always help Nepal. In the meantime, we want this citizenship provision to be kept in the coming constitution,
They have not finalized, but they are in the verge of finalizing. Even though we are not successful completely this time, there are some successes. At least they have put something that at least they have some non-residential Nepali citizenship options, and that is a little bit positive, and we will try to make it a complete statement that they will say, okay, anyone who is Nepali, they should be able to be Nepali, they should be able to keep their citizenship until they want. So that will be our goal, and thank you everyone for thinking of Nepal and helping Nepal during this disaster, and we'll be working together, and we need to be united. United we stand. Thank you for this kind of programs organized by American Society of Nepalese Engineers. This may be an eye-opener, and thank you Dr. Dakal again for giving this talk, and I'm privileged to be here. Thank you everyone for giving this opportunity. Thank you. Have a good evening. Next presenter, we have one more speaker. I would like to call up on stage Mr. Surya Langsar. He is the coordinator, finance fundraising coordinator of forthcoming annual conference of American Society of Nepalese Engineers, which is going to be held in New Jersey. Might be, we all know it. So I would like to call upon Mr. Langsar, please.
Thank you, Mohanji. Hello, everybody. I'm not really a speaker today. I'm just taking like a 2-minute time for just very simple short notice. My name is Surya Langsar. I am a board member of American Society of Nepalese Engineers and also a board member of NRN. Happen to be our NRN President, Dr. Keshav Patel is here. Thanks for being here. Exceeding our very short notice. I just invited him like half an hour ago. I would like to thank Professor Rajesh Dakal for being here from so far and exceeding our invitation here to present your very valuable information and suggestion for all engineers in the United States. I am being a structural engineer in the US. I understand completely what you are saying in your presentation. I would like to invite you as a organizing committee of annual general conference, an annual general meeting of American Society of Nepalese Engineers that's happening in New York area, actually in New Jersey, not Brunswick, New Jersey, that's 3 miles south of New York City. This is a great opportunity for all the engineers, Nepalese engineers living in the United States to join this conference and participate to discuss very important matter of this time, the earthquake in Nepal. That's the major topics. And there will be many papers and presentations on that occasions. And please do not miss it and participate actively so that we can support Nepal. I'm also a member, a coordinator actually, of the fundraising committee for that event. तपाईँलाई थाहा छ पैसा माग्न कति गाह्रो छ त्यसै पनि न्युयोर्कमा त 92 वटा संस्था छन् सबैले पैसा माग्दा यो अर्थक्वेकले सबै दिक्दा मैले केही नोटिस पठाएको थिएँ जस्ट लास्ट विक कसैले पनि मुन्टे मात्र फसाउनु भएको छ देख्दैथ्यो है अर्गनाइजिङ कमिटीमा चाहिँ अब फन्डरेजिङ गर्दाखेरि साह्रै गाह्रो भएको त्यसचोटि प्लिज हेल्प अस इन दिस म्याटर मैले अहिले तपाईँसँग इमेल र फोन नम्बर चाहिँ बाहिर पाएको छु साइनिङ सिटमा त्यसको आधारमा चाहिँ मैले इमेल पठाउने छु प्लिज हेल्प अस अन दिस म्याटर वाट एभर यु क्यान सपोर्ट लाइक $100 to $1,500 but you don't need to give more than $1,500 by the way र मैले चाहिँ त्यो फन्डरेजको लागि एउटा स्याम्पल बनाएर छोडेको छु अनि मैले दिपनाजीलाई पनि छोड्छु अथवा हाम्रो ढकाजीलाई पनि छोड्छु अथवा तपाईँहरू चाहिँ हाम्रो वेबसाइटमा गएर पनि त्यहाँको लिङ्कमा छ त्यहाँ क्लिक गरेर फन्डरेजको लागि डोनेसन दिन सक्नुहुनेछ र होपफुल छु कि तपाईँहरू सहयोग गर्नुहुन्छ भन्दै छोरा शब्द यो ठुलो छ थ्याङ्क यू
Yes, we all know fundraising is very difficult and very important stuff. Without fund, we cannot organize and we cannot carry out any conference and meetings. Now we have time came to call upon stage Mr. Rafael Discipulo, professional engineer, a structural engineer with over 23 years of progressive design engineering. He has worked on structures located in high seismic high wind area, including new and strengthening upgrades. Projects include low-rise and high-rise commercial buildings, as well as industrial and institutional. With concrete, he has worked on pre-stressed and post-tension concrete structures in both new buildings and in strengthening applications in combination with composite materials. He was previously the engineering manager of the VSL Washington DC branch. Currently, he works for the U.S. Department of State, where he handles projects in high seismic areas. Please, Mr. Discipulo, for example.
Good afternoon, everybody. First of all, I really want to thank you, and the few days that I get to stay in Kathmandu, one thing I learned is to do this. Namaste. Yeah. Good afternoon again, and Mr. Dakal presented to us a very good talk on. I did enjoy that very extensive presentation on starting from the nature of the earthquake and all the way to the different observations that he's got. He's got a lot more comprehensive pictures, and his talk even considers covers up to like governmental and procedural topics, and I thought that really encompasses everything. And so what I'm going to try to do is just to fill in some of the portions and cut out any duplications in what he's got, okay? Again, I was in Kathmandu only for 11 days. And I guess the only reason why I'm here is because of that and because Raj Tamang knows me. All right. Earthquake in Nepal, a little bit of the Himalayan tectonics. Dr. Dakal already covers this, and we know that Nepal is over there, that little swath of horizontal east-west land there, north of India. And you've seen this before, the tectonic formation that's happening there, and this action is actually what's causing all the formation of the ridges and valleys that we have in the area. It's actually what makes Nepal beautiful, the different mountains that we have in there. This is a plot of the earthquakes in that region, okay? And actually we can see, where's that? We can see Nepal is over here, and Philippines, where I'm from, is over here. So I guess that's another thing that I can say. I share with you the reality of the disasters. In 1990, there's this 7.6 earthquake that hit Manila and north of Luzon, and I was there to ride that earthquake. It's not fun, and there's a lot of damage also that happened there. Okay. And as we said, the mountains and the valleys in the Himalayas and all that is caused by the subduction zone that's happening between the Indian plate and the Asian plate. This is a plot of different earthquakes that has happened over time. One thing that I like about this is, if you note here, the rate of movement of the Indian plate into the Euro-Asian plate. And what you can see here is 4 centimeters per year. The USGS presenter in the US Embassy on, what's that, Thursday, May the 27th, I would say, Ms. Hughes actually said it's about more like 43 millimeters a year. And over here it's about 6 centimeters. Now, the different things that you see here are the plots of the earthquakes that has happened over a long period of time. And the 1934 earthquake, which I'm sure you all have read about, is right there. And you know that that's where we are. So I guess in the near future, I'm sure there's already an update of this graph, which would include the 2015 earthquakes. This is another plot of that's the Gurkha earthquake, and this one is the aftershock. One thing I'd like to point out here, which is actually okay. One thing I'd like to point out here is as the USGS presenter showed or mentioned, there's actually a perceived fault that goes north-south that way here, and they're feeling that there's another fault that goes north-south this way. That's all in addition to the east-west tending fault that we know exists around there. And so they were thinking that because of the, I guess, interpolation of the different earthquake, of the different aftershocks that, as you know, there's like hundreds of other aftershocks that happened. There was actually even a time when I must have been coming down from inspection of a building when one aftershock happened in the afternoon, and as we were driving away, a lot of people were just out on the streets, and we just heard it on the radio that an aftershock happened of about 4.3 that one afternoon. So there's many more of that. And all of these dots are indicative of those aftershocks. That's the Gurkha earthquake, and this is the May 12 aftershock that happened. Dr. Dakal already discussed this earlier, and about the nature of the earthquake that we had in Kathmandu. It's about the one thing that really jumps up to me was that the 7.8 or 7.9, whatever it is, my Gurkha knife says 7.9. For that long period of earthquake, there is in fact a lower magnitude of damage that the area incurred. For that much of a shaking, you would think that easily, if that were accompanied with severe vertical shaking, which is characteristic of hard rock formation area, there would be a lot more damage that we would have seen. So it is true that this slide here actually says that Kathmandu Valley did not experience the full brunt of the energy that the 7.8 could have delivered. Now this graph here shows the difference between the main shock, the main earthquake, and the aftershock. A little bit of a difference in the nature of the energy that was experienced. So there's no amplification of long period waves as this graph shows. What I have following are some pictures that I get to shoot on a weekend of going around town. So this is kind of limited, but among the things that I'd like to show on here is just the structural nature. How many structural engineers are in the house here? Okay. No? All right. This picture here is among you would see this in a lot of presentations, I believe, and it's indicative of the kind of failures that you would see on low-rise buildings. So if you note here, this I was guessing that this is the second floor plate, and the columns just buckled, and this building itself is translated and even hit the roof tower of the next one. You can guess some settlement on the front here. The next picture actually showed that a little bit more tilted. And so you can see that there's just massive translation that happened here. And damage even start from the roof, okay? And this separation here kind of indicative of just how much the building has tilted. There's a lot of this that you would notice, and I'm sure that you all stayed in contact with your friends over there, and I'm sure that Facebook photos and all that have been posted. And a lot of this, I would call this like, and the next picture too, a storefront effect. And this is another picture. This is just right across the street where this happened. Okay, so as you can see here, one floor just vanished. One floor just vanished. The column supporting this story just vanished, and now you have that one floor, the top floor that's just sitting on the one underneath. There's no telling what happened here. Over time, the owner may have decided, I want to build another floor. Maybe that's what happened. Okay, but all sorts of things. There's a lot of history that that we have to get into as we evaluate buildings. You must have seen this in Dr. Dakal's presentation earlier. We were on our way to, I believe, Bhaktapur. This is off of the ring road when we saw this, and I could not resist the urge to tell our friend Rafesh, who's driving us around town, for the chance to come closer. And here you can see this. This is a building that's under construction, all right? It's under construction, and for the structural engineers, you would appreciate this more, the fact that not all the dead loads are there yet. And in the generation of inertia forces, there's no participation from any live loads yet, all right? So, and even then, we have this failure. This story just crashed down to it. Again, to my mind, this is what I would describe to as a storefront effect, you know? The owner would like to have as much free space at the front, and must have told the engineer or the builder, whatever case it is, not to have any walls transverse to the front, which we know. Walls really deliver lateral framing strength that we would all need. And this is another example of a very skinny column, you know, and I would even guess that there are really no shear walls at all in this building. You can see the columns are, I believe, the typical 9 by 9 with just 4 small bars and not enough lateral reinforcement. Next example are low rises with the classic failure on the walls this way. All right. Again, as Dr. Dakar was saying, we gotta differentiate between non-structural damage and structural damage, but at the same time, these are indicative of how much translation the building has undergone during the shaking. Another view of that same building with those classic crisscross that failure, crack failure between the openings. And those failures are not only in the low rise. This is maybe somebody can help me locate this. We saw this, and I forgot which part of the valley this is, but it's grande. There's about 4 or 5 buildings of this size in the area. One behind is just about to get done. They're close to plastering and finishing that. There's another building close to it where it's just starting, I think on the 3rd floor only. And the one telling thing is this. If you look closer, you can see separation of the walls with the frames on the ground floor, and some crisscross also that's happening. And a little bit more close up, you can see that. I got another picture right inside the lobby, and there's just a lot of cracking that happened in the wall. Just the same for the low-rise building that I've shown you before, that same thing happened also on a building that's still under construction. You can see the failures there. I thought that's a good feature that the design included an expansion joint. It looks like an expansion joint that would have really helped the buildings perform a little bit better under earthquake. The next few slides are all from EERI, and I got a URL for you, and I would encourage those of you interested to visit this site. And there's a lot of observations and good knowledge that they share also here, and pretty much they summarize the damages to low-rise and medium high-rise. The big effect is here, what we would call in structural engineering as ridge amplification. And I guess Dr. Dakal already touched on this earlier. That in fact, if you're on top of a hill, as the waves come, you can just imagine as the waves come, if you're at the ridge, you're gonna experience more rotation. It's just like if you're riding on a boat and starts to rock and you're at the rooftop. And here is another example of what I mentioned as a storefront effect. Yes, for greater visibility, the owner would not want any walls going transverse or anything like that. Which actually structurally we can compensate for that, like another wall just on the first bay inside and then to the back, just to take care of the torsion that happens in the building. But the sad thing though is that even on some buildings that I've seen that are being under construction, I'm seeing the lack of competent shear walls transverse to the storefront, and with the prevalent practice of using unreinforced masonry, to me, that's something that the industry, local professionals, and even us here, engineers in the U.S. can help educate the local guys. Now, this is in this slide. I thought I'd just include this because I think it's very important to recognize this, and as I like what Dr. Dakal was saying earlier, that we as engineers, especially the local ones, we can be advocates to avert future disasters even the next time that an event happens. And it takes just reaching out to if you're passing by construction, as he said, just educate people. Because here you can see that the owner-built construction is really by far the most custom, I guess. That's how most projects are going on. And there's even one house that I went to. I was asked to participate to a group in the assessment. It was freshly built. I can still smell the fresh paint. 4 or 5 stories, costing about, 900,000 rupees or something like that. That's a lot of money, right? But then, I was just a hanger-on, I guess. I was just invited to, and not give any professional opinion. But I noticed that in that newly built house, walls are just, the thin, unreinforced, hollow clay brick walls. And we know that they don't offer much of resistance. I thought for 4 or 5 stories, you got to have substantial walls that are in the 9 inches thick already and really, really well placed in between your concrete frames. So this is I thought is one area where engineers can play a better role. Building performance findings, you can read through all this, but really the things that I want to highlight is this: the difference in performance between engineered and non-engineered. Okay, and then the other thing is this: seismic codes that follow. But then again, how do you expect a building to comply with seismic codes if they are owner built, or if they are built by just the owner talking to a mason? No. And then the other thing here is the non-ductile detailing observed in most buildings. And as was mentioned earlier, there is a unique construction design practice in Nepal. We use a lot of bricks over there, right? Unlike here in the US where we use a lot of reinforced concrete. But I just got to say that there is a proper way of using even unreinforced masonry in seismic areas. There's a place for it, all right? But it takes the engineer giving the necessary input and the building owner allowing the adoption of those proper detailing. It's gonna cost some money, but it's gonna give them a good product. This is another thing that jumped up to me as I was reading this ERI presentation. That there are codes out there, but at the same time, it seems like the code is a little outdated. And I'm happy to hear that we have professionals, experts like Dr. Dakal working with the local government to highlight the fact that we need this. Okay? We need an update on this. URM buildings, I kind of mentioned that already. And the next thing really that I'd rather delve on is I may be singing the same song here that Dr. Dakal said, but as we were talking earlier, the engineers really have to be at the forefront, especially in this particular time. There is so much advocacy that we can do, and there's so much. I believe right now is a good time for us to get people to listen to what we're saying. That we gotta build better structures. You guys gotta follow talking to the homeowners, okay, who would like to get something done through you. It's our time to let them know that. There are things that we gotta do, and there are things that I will have you do, okay, Mr. Owner, so that we can get to a good product. And we gotta be able to walk away if they insist on doing the old way that resulted to all of this damage. All right, the update of the building code, adoption of modern seismic design practice, all of this is really available at this time and age. I mean. I was there for 11 days, and I was not really even every day. There's internet connection. When there's internet connection, there's websites that you can go. There's professional materials that you can get to. So there's really no excuse for anyone now, at least for that region, for that area, to say that we didn't have the details, we didn't have the design information, we didn't have the guidelines. There's a way to access these things. And then implementation, as Dr. Dakal was saying, no amount of rules, no amount of updates on codes will be good unless implementation is really seriously taken. I understand that in all developing worlds and in my work with the Department of State, I get to visit many different areas, like Nepal, and it's even happening in many other areas, the Philippines included. We got our own sorts of challenges in inspection as well. But the message, Mother Nature has given us a message. She's gonna do her thing at her own time, and we gotta be prepared, responsible enough to participate in building projects, houses, whatever it is, high-rise or low-rise or whatever, even dams, okay, that can withstand the forces of nature. All right. And my last last slide here is for those of you that are well-meaning people. I know that after you've heard of what happened in Nepal, there are many of you who would have started thinking about maybe I can do something more for Nepal, for Kathmandu, and maybe start a relief organization, fund drive, or whatever. My simple message is that look in the internet as well, and there are organizations that maybe you can network with. For the design professionals, EERI has very good information. I believe there is even an upcoming presentation in UC Berkeley sometime next week. If anyone is interested, I can get you the link. And then the other thing is there are existing NGOs that are already operating with some projects already going on in Nepal. This one here, Build On, is I believe based in Connecticut. But I was just talking to their consulting structural engineer, who happens to be somebody I know. He's from the West Coast. And I believe that they have already developed a template school design that they have already started building on the east portion of Kathmandu, and they would like to continue to move towards the Kathmandu proper. And if that's something that you would like to network with, I'd be happy to provide the contacts. Again, thank you very much. Thank you very much. I'm humbled with the presenter, and more so, I'm humbled with the opportunity to be in Kathmandu and see the resilience of the people. And the one thing that I'm happy also to note is that even with that much of damage, when there are people that have to line up for like water or something like that, people are lining up. Well, they're not panicking. They're not going into each other, and they are calm. And I really admire that. Thank you so much.
Okay. Thank you so much.
We had a quick video you want to
Yeah, we have quick video that could be very good, precise, please.
Yeah, sorry about this. I forgot about this video. Is there sound?
What happened to the sound?
There's no sound.
I'm not sure there's sound on here.
Maybe there is no sound here.
It's a long one. How long was that?
Thank you so much, Mr. Disipulu, for your precise and informative presentation. I very much like your pictures. Pictures is so clean, clear, it speaks something. Pictures itself speaks something. We have some question answer, right? Right. Let's have some question answer. We have 3 to 4 questions we will take. I think DDJ will conduct this question.
Presentation, we really appreciate that. My question is basically, you are from Philippines and you have been in USA and you visited Kathmandu, Nepal. So your experience really tells us too many things. For the purpose of earthquake resistant structures, concrete are heavy construction, bricks are heavy construction, stones are heavy constructions, and they are not good for the earthquake. Compared to what you have in Philippines and what you saw in Kathmandu, do you see any alternate material that they can start using in Kathmandu area for the purpose of earthquake resistant construction?
Yeah, thank you for the question. The answer to that is really going to depend on the kind of building, the kind of project that you have. If you're going to go high-rise, the only two choices really would be reinforced concrete or structural steel. Those are the only two choices you got, and so it's the same thing that's being done in the Philippines for like 50 stories, 60 or 70. It's going to be either concrete or structural steel. The one thing that I see a lot being done in Makati area, like in the national business region, is reinforced concrete shear walls and what structural engineers would call dual systems, where there's majority of shear walls that are being done, and then the rest are like vertical carrying elements that are there for the ride. Ductile detailing, of course, is observed because it's a necessity, and at the same time, that's also among the things that the city people would look for as they review towards permitting projects. Bricks cannot be avoided though. And not only in Kathmandu, I've been to like Kyrgyzstan, Uzbekistan, those areas there, Kazakhstan even, and bricks are being used, okay? And I just got back also from a trip in Turkey, and hollow plate tiles and bricks are also being used. That's true. Bricks and masonry, they weigh a lot, and seismic forces are related to inertia forces, which are, of course, related to the mass of the elements. But at the same time, there's engineering solutions for this. There are just things that we can do on the structural design side so that we can properly design for the forces that are associated with the heavier construction materials like bricks.
Cost, if you want to design the building not to have that much of substantial damage by this level of magnitude, let's say 7.8, on the top of the conventional cost that has been built in Nepal, how much extra percentage is going to cost?
I guess my first answer there is I have not been pricing professional fees for a while. So. But kidding aside, I don't believe that there's much more effort in doing seismic design along with the design for the rest of the building. Note though that structural design covers all of this, okay? You cannot do a complete and design without covering for the lateral forces, whatever it is. It may be earthquake, may be wind, but all of that will have to be in your product as a structural engineer. In terms of additional effort, well, there are already computer programs that are available, so that in your 3D model, which you typically do anyway, whatever it is, whether you're on a low seismic zone or a zero seismic zone, high wind area or low wind area, you always have your 3D model anyway. So it's just a matter of doing that extra step. That's right, it's an extra step, but if I take a guess, it's not going to be additional of 25% in the fees.
Even the construction cost?
What's your question?
We are hearing almost every day, almost more than 400 after stroke is going on, and it's still going on, keep going on. And every time I call to my home families, and they are so scared, so stressful. So some British scientists already forecasted it will be happening in the western side of Nepal, and everybody asking what to do. You guys are in America, we are so much people. Do you have some answers so that we can say, hey, don't really this will happen? It might be one. It's very hard to answer, but that is the one stress, painful questioning all the time. Is every day going after stroke is going on.
Yeah, what I've heard is this, that the 7.9 that happened in Gorka and then followed by a 7.3, that was a surprise to even USGS. But what I've heard is that between those two boundaries, if I may say that, between those two boundaries, they're not expecting anything major in the same range as the 7.8 or 7.3. But the fours and the fives, they're continuing to say that we will continue to have to deal with that. The nice thing is that most of the structures that survive the 7.8 or 7.9, call it 7.3, and the hundreds are the fives and that. So does that mean that I'm telling people not to be complacent? No, we got to continue to take precautions. We got to be aware of where we are and really take notice of the changes and the how do you call this, and the reaction of the buildings that we are in to each of the events.
People know how, but the experts, the international experts, they have been giving that message quite consistently over the last 2-3 months. So whoever visits there, they keep on telling that, okay, this fault has ruptured, the energy has been released, but there are other faults which haven't ruptured over the last couple of hundreds of years, right? So they are due for a big earthquake, and that is not a new information, or there is no news in it. We all know that, okay, but nobody can precisely predict when and what magnitude. Okay? So we know that it is in a seismically prone region. So earthquakes is not a matter of if for Nepal, it is just a matter of when, right? So it's going to occur. So and regardless of how big expert he or she is, nobody can. I think that's how we should console our people back home. Look, because as I have been saying, earthquakes don't kill people, bad structures do. So if we do build or design and build our structures properly, then earthquakes can shake buildings. You can't stop buildings being shaken, because earthquakes, when the ground moves, whatever structures are founded on the ground will move automatically, right? So but there is there is no danger about things moving, but danger comes from when during the movement these things collapse and bury people in, right? So the message we should say to all our nears and dears back home is, look, because earthquake is a natural phenomenon. Science has developed a lot, but hasn't yet conquered nature. Let's leave the natural part behind, but damage and fatality comes not only from the natural part, it comes from the artificial part, which is also the building.
So I would like to thank you, all our participants, providing us this time. You guys are supposed to be with family. Today is family day, weekend. Without your participation, this program will not happen. Thank you so much participating in this program. And thank you again, Dr. Pakal, all the way from the New Zealand, and presenting this very precise and interesting presentation, sharing your experience from Nepal, and also Mr. Discipulo, sharing the Nepalese earthquake experience and sharing your experience in Philippines and your expertise. And last but not least, thank you our reporter, media persons, Vishwaraj Thapaji and Khem Bhattachan from media, and thank you the Chantilly Regional Library providing